Hello and welcome back for another VMK in the C++ series. In this VMK, I'm going to be describing how to get colors inside of your console windows. So let's jump into Visual Studio and get started. I'm going to just start a brand new project, so go File, New Project. I'm going to be using a Win32 console application, and for the name, I'm just going to call it, I don't know, console color, and hit OK. Uh, Under the application settings, you should have console application selected, precompiled headers enabled, and everything else disabled. Hitting finish, that generates some files for me. I've changed my template, so what you are going to see is going to be slightly different from what is shown here on the screen. So I'm just going to show you what I have. My main inside of consolecolors.cpp contains just a string out. Inside of stdafx.cpp, I include stdafx.h. Inside of there, we have a include for our target version.h as well as some standard header files, which we're going to need to actually output strings to the console. We're not going to be using this. We will be using that. We won't be using these, so technically we won't need these, but I'm just going to leave them in here. And the target version just basically includes this here. So if we were to press Control F5 with this code and give it a run, we see that our console opens up and we have text output to the screen. Also, one thing that you'll want to check is inside of the project settings. If you right click and go to properties, right now you'll notice that the character set is set to Unicode character set. That's going to be a problem a little bit later on, so just to avoid that, I'm going to switch that over to multi-byte character set, just because I typically don't program in Unicode. So hit apply, hit OK. Again, if I press Control F5, it's going to rebuild and we'll have the exact same output to the screen. So we have our console. You'll notice that the title of the console is Windows System32 Command. We have maticnose.com written there, and then press any key to continue. And the reason why it's staying open is because I'm pressing Control F5 on the keyboard as opposed to just clicking the F5 key or the run button. You notice if I do that, it immediately opens and then closes the console window and you actually can't see the output. So I'm always pressing Control F5 for this demonstration. Okay, so to start off, I'm going to change the title of our console window. There's a Windows command called set console title where you can type in the text that you want to display and that's what it's going to show. Now if I try to compile this and run it, you'll notice that it gives me an error saying set console title identifier is not found. The reason why it's not found is because we're missing a header file. Now if you're not sure which header file you need, you can just copy that string into your browser. So for instance, if I do that inside of Google, it brings up the function definition here. So if I click on that and read through the documentation, you'll see that near, I think it's the bottom, they should have a description, here it is here, that tells you the header that you need. So the header for this function is inside of wincon.h, which means that we should be including windows.h for it to be accessible. So going back into stdafx.h, right at the top here, I'm just going to add in an include for windows.h, and this is going to have all of our console API that we're going to be using in this VMK. So let's make that change. Go and select stdafx.cpp, compile that, and now we can go back into consolecolors.cpp, and this time when we build, we can actually build that because it's now able to resolve that. So if I press Control F5 and run it, we see now the console title bar has changed to the text that we typed in right there. Okay, now that we have the title defined, let's take a look at how colors work inside of the console. Colors are all handled with a special API that's available to us from Windows. And this API all works based on a specific handle. The handle that we need is a handle to our console, and then all the functions that we're going to be calling is going to require us to pass in that handle to the console so then we can manipulate things within that console. So the first thing we need to do obviously is get a handle to our console, and the way we do that is with the following line of code. I'll just replace this std out statement with get std handle. Which handle do we want? Well, we want to get the standard output handle, which is our console window. So I'm just going to save it here inside of this local variable called hScreen. With this handle, we can get some information on our console. So there's another function called getConsoleScreenBufferInfo. And the way that this works is, again, we have to pass in the handle that we got up here, and then we also need to pass in the address of this thing called ConsoleScreenBufferInfo. This is a struct that we can go and take a look at. It contains a size, a cursor position, some attributes, some rectangle sizes for our window, and some maximum window sizes that are specified using coordinates. So by doing this right here, we're saying the handle that we're interested in, please return to us some screen buffer information. So after calling that, we can then go and take a look to see what values were returned from that function call. So I'm going to write some std out statements here for the buffer screen size. So we're just grabbing the size, the x coordinate, and then the y coordinate, printing that to the screen. And then the other interesting things that we have here is the parts of the screen or the console that are visible. So we can get that using the left, right, top, and bottom properties from the SR window rectangle that's stored inside of that screen buffer info. So let's go and compile this, give it a run, and take a look at what it outputs. For my configuration, it's saying that our screen buffer size is 80 by 300. Our window left coordinate is 0, our window right coordinate is 79, our top is 0, and our bottom is 24. So what does this all mean? Well, that tells me that our window here, the black area, is exactly 80 characters wide. So that means that the first one here is index 0, and the rightmost one is index 79. That's where those two numbers are coming from. The height of this window is 25 characters tall, which means index 0 is the top one here, and index number 24 is the very bottom one down here. Now it says that the screen buffer is 80 by 300 and not 80 by 25. So I'm able to see 80 by 25, but I'm actually have a buffer that's big enough to hold 80 by 300. So we can go into the console properties and actually see these numbers under layout. Under layout, the screen buffer size has been defined here as a width of 80 and a height of 300. So that's where we get the 80 and 300 from. But you'll notice that the window size is set to be 80 by 25, and that's where we get those coordinates there from. So if you change these numbers, then the output from the console screen buffer info structure will coincide with what you have set there. So now that we know how large our screen is, we can go and start manipulating things on the screen, and we'll see how to manipulate the cursor in a second, but first let's take a look at how colors work. I'm going to comment this out here so that it's not displayed to the screen. Okay, let's take a look at this command. There's a command called setColorTextAttribute. We're passing in the screen, so this is the console that we're playing with, and I'm saying I want the text attribute to be set to foreground red. Then I'm going to print out the statement. This is a string of colored text, and let's take a look at what happens. Press Ctrl F5, and notice that all of the text on the screen here has now changed to red. So this is a string of colored text, and press any key to continue is also red. Press any key to continue is text that was automatically generated because I'm pressing Ctrl F5. That's not actually in my program. You'll notice that I don't have a std_cout statement that says press any key to continue. So if I actually wanted to make sure that when my code runs, I change the color to red, but then afterwards it reverts back to the defaults, then we need to actually get the default values from the attributes from this info structure and revert it back before we go and return. So to do that, we can, after we get the information here, we can store the default colors from the screen buffer info, and that's all stored inside of the attributes. And then once we have that, to reset the colors back to what they previously were, we're just going to call that same command, setConsoleTextAttribute, but this time passing in the default colors which we stored up above. So now when I press Ctrl F5, you notice that the string of text up here is red, but press any key to continue reverts back to the default, which is this light gray color or light white color. So you may be wondering, okay, well, we can change the color to red. What other colors can we change it to? Well, it turns out that the color that you specify here, actually in the definition here, you'll notice that it's asking for a word. And the word defines the color, and the color here, foreground red, is defined as a binary code, which you can see here in the tooltip. It's 0004. So if you go and take a look at the definition for this, we have a few other colors that we can play with. We have foreground blue, foreground green, foreground red, and foreground intensity. We'll talk about the background in a little second, but first let's take a look at just the foreground. So each of these values are actually bits that are represented here. So blue is bit 1, green is bit 2, red is bit 3, and intensity is bit 4. If you're not too familiar with how bits work, then I recommend you take a look at VMK number 1 for number systems. Will describe the different kinds of hexadecimal, binary, and decimal systems that are typically used in programming, so you'll understand what I mean when I say bits. So now that we can see that that's the way that our colors are defined, if I wanted to change the color from red to, I don't know, let's say yellow, how would we do that? Well, we can see we don't have a foreground yellow option here, but we do know that the color yellow is comprised of red and green. So if we actually combine those two bits together, we would do it like this. We go foreground red, ORed, bit ORed with foreground green. Now when I run this, you'll notice that the color is no longer red, it's actually now yellow. It's a muddy yellow, but it is yellow. There was this other command here, foreground intensity. So the way that these colors work is you have 3 bits to define your color, and then you have intensity to actually change how bright the color that you've chosen here to be. So right now this is muddy yellow. If we want it to be bright yellow, then we would do something like this, where we would take the yellow color and OR it with intensity. Now if we run this, we'll see we have a muddy yellow above and then a bright yellow down below. Now intensity can be ORed together with any color that you want. It doesn't have to be a mixture of something. So you could just do intensity of red. So now we have, let's do this. So we have regular muddy red and then bright red here. If I control F5 and run it, you'll see there's our muddy red and then there's our brighter red down below. If you want to see all the colors that are supported inside of console, we can write a very simple for loop here that iterates through all the different colors and displays them to the screen. So let's take a look at this. I'm going to take these out and take a look at this for loop here. So we're creating a for loop that's going to go from color 0 down to color 15, and we're going to increment it one at a time. We're going to set the text color to that color inside of the for loop, and then we're going to print to the screen color number whatever, and we're going to pass the color value to this function called decode color. So what's decode color going to do? Well, it's going to be a function that's going to tell us which of these configurations we're using for this particular number that we're generating inside of this for loop. So this function takes in a word, which is the color, and we can bit and it with foreground blue. If this bit is high, then we're going to display the string of text foreground blue. If the bit for green is high, then we're going to concatenate foreground green to that string. If it's red, we're going to add red in there, and if it's intensity, then we're also going to add intensity. So now, if I press Control F5 and give this a run, we'll notice that on the screen, we're getting all the different colors available to us. We see we have blue, green, this kind of turquoise color, red, magenta, this muddy yellow color. Then we have the default sort of light white color. Then we have a grayish color, and then we have the brighter versions of everything there. Now, one thing that isn't being shown directly right now is the very first one. Color number 0 is actually getting printed here, but we can't see it because it's black on black. So it's actually black text, and we have a black background, so we can't really see it. But we'll get to that in a second. So now that you know how to control the actual text color, let's take a look at how we can control the background color. we see back here that we have bits defined for the foreground, and we also have bits defined for the background. Well, it turns out you can mix these together to give you an overall background and foreground text color as you display things to the screen. You'll notice that these bits here are shifted by 4 compared to these bits here. So background blue is exactly 4 bits to the left of where foreground blue is. And background green is 4 bits to the left of where foreground green is. Background red is 4 bits to the left of foreground red, and the intensity is the same. So if we wanted to generate a for loop that displays to us all the background colors, we can do the following. We'll take our for loop from 0 to 16 again, but this time, every time we generate a color, we're going to shift it 4 bits to the left, and then we're going to apply it to our function here. Then we're going to output it, same as what we were doing before, but now we also need to go and modify the decode color, since the decode color right now only takes care of the foreground colors and the foreground intensity. So down below, let's just add in our bits for our background colors. And so we have background blue, background green, background red, and background intensity. And now let's give this a run. Control F5. Now you'll notice that we're not changing the foreground color of the text. The text is actually black, but we are changing the background color behind the black text. And again, we can't see the very first one because we have black text on a black background. But everything else we are able to see with our eyes. So if we wanted to change this so that we can actually see the very first one, then we can add in an extra if statement here saying if we are basically looking at color number 0, which is the very first one, then take the color that was generated here and also OR it with foreground red, foreground green, and foreground blue. So what's that going to do? Well, red, green, blue together is going to give us white. So we'll have white foreground text on a black background. So let's Control F5, give that a run. And sure enough, we can now read the very first line. We have color 0, foreground blue, foreground green, foreground red, and it has a black background. And all the other ones have black text with a colored background. Which means we can go back to how we were doing things for the foreground and also show how the very first line looks with black text and a white background. So we can do that where we have our for loop. We check to see if color equals 0 here. So the very first one we know is going to be black text. So we want to change the background to have red, green, and blue together. So this is going to give us a white background with black text on top of that. Every other one we're just going to output it directly. So let me comment out this for loop and run this code. And now we can see we have color 0. We don't have anything displayed here because we actually have black text, which is the absence of having one of these values. So that's why we don't see any text beyond color number 0. And beyond that, we have a black background with colored text on top of that black background. So there we go. Now we know how to control colors, both foreground and background. And well, I guess I could also show here. So if we wanted something crazy like a yellow foreground color with a background color of green, then we can do that, and we'll just display a dummy string of text here. Control F5, and now we get orange text on a green background, which is very hard to read, but we do have control over exactly how we want to show things on the screen. Okay, so that's colors. Let's move on to how you can control the cursor. With the same API, we have access to being able to position our cursor anywhere we want inside of that console window. The way we do that is I'm actually going to create a function for us to make this a little bit easier to do. And it's going to work like this. Let me just copy some code here and paste it in. So we're going to be outputting to the screen 1 start, 2 moved 35, and 3 moved 510. So in other words, what I'm doing here is I'm saying I want to be outputting three strings onto the screen, but the first one is going to be located at the default location, which is in the top left-hand corner of our console. But the next one, I want to move this many coordinates over, so this many characters over, and then 5 rows down. The next one, I want to move 5 across and 10 down and display this text here. So let's take a look at how we can implement our move cursor function call. I'm going to scroll up here and place it right over here. So move cursor takes in two parameters, an x and a y coordinate. Both of those two coordinates we need to construct a chord out of it. So we take the x and the y and just pass those in there. And then we have a function called set console cursor position. Again, it takes in the handle to our screen and it wants a position of where we should place our cursor. If I try to compile this right now, it's going to fail on us because it says hscreen is undeclared. It's undeclared inside of the scope of this function, so that's why it can't find it. To resolve that, what I'm going to do is just take this and make it a global variable and define it here at the very top. Normally you would do this in a much nicer fashion, so wrap this up in a class or something and manage your screen handle appropriately, but just for demonstration's sake, I'm just making a global so that I have access to it inside of this function. So now if I press Control F5, we see we have the following. Our first line of text is displayed here. Our second line of text is it's at index 30 across and index 5 down. And then the third one here was 5 over and 10 down. And then the print any key to continue is displayed right after the very last cursor location, which happened to be after that bracket. Since we're able to control the position of where we display things when we decide to print something, we also can run into the cases of we can basically start overlapping text. So for instance, I can say here, let's go and do 35 and 5. So you'll notice up here, I'm starting at location 30 and row 5. And here I'm saying move over 5, but stay on that same row. So this line of text is going to overlap this line of text up above that I previously printed. So this should be 35 and 5. So Control F5, and sure enough, that's what we get. So we get 1, 2 moved, and the rest of it was cut off because it's now getting overwritten with 4 moved, 35, 5. 3 moved is still down here because that's where we told it to be. So that's basically how you can move your cursor around so that you can display text anywhere you want inside of the console. Up till now, I've been basically describing how you can go and render things on the screen by specifying the color and then rendering your text. You can actually do this in reverse order as well. So for instance, if I do the following, so I'm placing my cursor at 0, 0, drawing this string of text to the screen and moving it down one row, same line of text, and then the next line, same text, and if I run this, we see we just get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3 times on the screen, and they're all in the default color. Well, after printing all of that, I can then execute a command and tell it to go and color the text that's already been sent to the console. So I'm going to generate a new function called setColor where you pass in some coordinates. So the first two values here are x and y, where you want to put your cursor. The next value is how long or how many characters you want to go and modify. And then the last parameter is how you want to modify it. So what I'm saying here is I want to go and change row 0 starting at location number 5. For the next 6 characters, I want to make them all white, bright white that is. And then for the next row below it, I want to change the color to be bright red. So let's see how that works. Well, we need to go and implement this set color function. So let's go and implement that. I'll put that right below move cursor, which was up here. This one, you pass in x, y, the length, and the color. The x and y get dumped into a position coordinate. The length gets dumped directly into our fail console output attribute function call. So this guy here takes in our screen handle. It needs to know what color you want to go and set at this specific location, how many things you want to be changing, and it also takes in a address for a parameter here that gets returned back to you. And this value tells you how many actually got changed for you. So if we wanted to see that value, we could then print it out, but I'm not going to because that's going to mess up this example initially. So let's just press Control F5, give this a run, and see that sure enough, we have our default colored text from 0 to 9, 0 to 9, but then we went back and said, well, in the first row we wanted to change the text up here to be background white with black text, and over here we wanted background red with black text. And if we were to go into this function and just do an std cout for the written value, Control F5, we'll see that we're getting 6's displayed here because 6 is how many things that we're actually changing. 1, 2, 3, 4, 5, 6 are how many we changed in the first one, and then 6 more for the second one down there. So typically I don't use the written, but you do have that value returned back to you from the API in case you do need it for something. So initially I showed you how to set the color of something and then output text. Well, you can also output text and then set the color of it this way. There's one other thing that I wanted to show you guys. Let me go and comment that out and show you the following. When writing console applications, I typically will use all the functions I've showed you up above, plus this one I'm about to show you. So in this example, what we're going to be doing is just displaying to the screen a block of text. So if I Control F5, we see we have that text to the screen. With console applications, you typically will position something somewhere in your console, display it, but then when you want to go and update something, you'll need to remove it from the buffer. The way that I typically do that is with a function call called clear area. So clear area, the way that this works is you pass in some coordinates and a length, and it will go and clear whatever is at that location. So let's take a look at how I've implemented clear area. Clear area uses another API from the console APIs called fill console output character. We're passing in the x, the y coordinate, and the length. So the x and y coordinate get passed into a structure. And this function call here needs the screen handle. It needs a character for what character you want to use to fill at the specific location, and then how long or how many of these characters do you want to fill with. And again, it's going to return to you how many values were actually output to the console. So now, if we take a look at what I'm doing here, I'm dumping all of this text to the screen, but then I'm going back and saying, starting at location 25, row 3, I want to clear the next 20 characters. Then go to the next row and clear the next 20 characters, and go to the next row and clear the next 20 characters. So now if I run this, you see we get the following output. We're basically cutting a hole in our console output because we are clearing the values that were previously stored in there. So by mixing and matching your move cursor, your clear area, and actually specifying the color and things like that, you can create simple animations or simple kind of graphical user interfaces within your console to give you sort of rudimentary GUI inputs for console applications. So that's all I wanted to show on this VMK. If you have any questions about this VMK, head on down to the forums by clicking on the thread link for this VMK and posting your questions there.